I have two goals today. The first is really to talk about computational linguistics and how it can contribute to the teaching of languages, particularly in the area of morphology, which is important for indigenous languages. And second, I want to kind of make an argument for collaboration among different fields, including computational linguistics and pedagogy and linguistics, in preparing teaching materials for these languages. So first, nowadays, almost no language is taught anywhere without using computers, whatever country we're in. And one approach to computer-assisted language instruction is to use ideas from areas like artificial intelligence to make the program smarter. So a smart program could be smart because it understands something or knows something about learners, about how learners learn. Those kinds of programs use ideas from artificial intelligence and cognitive science. The kind of program I'm going to talk about is smart because it knows something about the language. It actually includes a model of the language itself. And these programs are based on work in computational linguistics in all sorts of areas of language, because computational linguistics is a very broad field: syntax and semantics, lexicon, discourse, and I'll be talking about morphology. So, as you all know, indigenous languages of the Americas tend very strongly to be very complex languages morphologically. That's not true for all of them, but it is generally a kind of areal feature. So what I believe is that this isn't just a matter of putting inside the word what other languages put in the syntax. I think many of these languages have fundamentally different ways of organizing concepts. In particular, many of them take a relatively small number of units and combine those units in productive ways to produce the large number of units that we all require. So I don't have good examples from these languages, but here are some examples from a North American indigenous language, Nujal, which shows you that these simple morphemes in English on the right correspond to multiple morphemes in all of these cases, where each color is a different morpheme. So even the word for 8 actually consists of 2 different morphemes that are combined together. So this is a fundamentally different way of organizing the language. And if we're going to teach these kinds of languages to students, we should actually make them aware of this, right? So the teaching of morphology for a morphologically complex language is certainly going to involve making students aware in some way of the structure of words. How we do that depends on our theory of language teaching. And as Nora said yesterday, there are many different theories, but there would be really no way to avoid approaching the structure of words. So if you were going to use computer-assisted teaching to teach morphology, you would want the software to make the structure of the words explicit. You'd want ways to make word structure something that students could see, obviously. But how would you do that? One way to do that would be simply to include a whole bunch of specific examples. We would think of that as a kind of canned approach. But a smart approach would have a program that actually knows something about the morphology of the language. And that's what I'll be talking about. These are ideas from computational linguistics. So in computational morphology, there are 2 sorts of techniques that we work on. One is morphological analysis, and Jonathan will be talking about this as well in his talk, which converts a word, a surface form, to some kind of a representation of the structure of the word. So a surface form is analyzed into its constituent morpheme. So we take a word like kinawilo in Quiche, which means you see me, and we could break it into the separate pieces which represent the different morphemes. More usefully, we could break it into something that represents something of the constituents, the grammatical structure of the word. So this consists of 2 parts, one which is first person singular, another which is second person singular, and it's informal, and this is in the incompletive aspect. So these are 2 ways that a morphological analyzer could take an input and convert it to another form. We also want to go in the other direction. We want to start with an abstract representation, and we want to convert it into a surface form. So we want to start with something like that, structure, and convert it into the word kinawilo. Now, whether we actually make this explicit for students or not, again, is another matter. At least we want them to be aware of how words are structured. So what would be involved in using these ideas to actually teach morphology? I'm not going to present a lesson because I don't actually have that. What I have is a program that analyzes words and generates words, and I want to suggest how it might be used in teaching the language. One advantage of having a smart program, as opposed to a program that has just canned examples in it, is that it's robust. That is, a student could type in a word, a new word, that the program had never seen before, and the program, because it understands how to analyze words, would be able to extract the structure. This wouldn't be possible in a system that didn't have a smart morphological analyzer in it. A smart program is also easily extensible. If you wanted to learn, if you want to add a new word to the system, you simply add a new word to the system, and then it automatically knows how to generate all the different forms of that word, because it has the rules built into it. So this has lots of advantages over an approach which doesn't use a smart morphological analyzer and generator within it. So I'm going to show you a program that works for Quiche and a little bit of Quechua. It does two things. It takes the word and breaks it into morphemes, but it also shows what those morphemes mean, so it gives you a grammatical representation. It also accommodates multiple analyses. As you know, words may be ambiguous. A word may have different possible segmentations and structures, and we want our program to handle that. So it can give multiple analyses of a word. So let me actually go to the program to show you. Okay, so we can type in a word up here, like misspelled it. That's just to show you that if you misspell it, it doesn't work. That's it without any stuff. Okay, so it breaks this into morphemes here, and each of these morphemes appears in the slot where that the language has available to it. In most languages that have complex morphology, there are slots which appear in fixed positions, and some of them are empty, some of them are filled in different words. Down here you have a representation of the root. This is the root of the word, which means C. It's the incompletive aspect. The absolutive part of the word, which represents the object in this case, I'll tell you more about absolutive in a minute, is first person singular. The ergative, which represents the subject, is second person singular informal. This language makes a formal, informal distinction. And this simply means that this appears at the end of the sentence. There's actually a slightly different form. Let's change this and see what happens if we now produce. So now we're going in the opposite direction. Now we're starting with this, and the output is going to be the word up there. So you see that when you change the non-final form, you actually don't get the suffix. So we can change this, for example, make it formal instead of informal and see what happens. You see that the formal is actually represented by this separate word that appears not like a suffix, but as a separate